After the core is positioned and the two halves of the mold are clamped together, the casting is performed. The gating and the riser system in the system must be designed to deliver liquid metal into the cavity and provide for a sufficient reservoir of molten metal during solidification shrinkage. Air and gases must be allowed to escape. Following solidification and cooling, the sand mold is broken away from the casting to retrieve the part. The part is then cleaned, gating and riser system is separated and sand is removed. Finally, casting is inspected, completing the casting operation. One of the hazards during pouring is that the buoyancy of the molten metal will displace the core. It results from the weight of molten metal being displaced by the core, according to Archimedes' principle. This force is described as Fb equals to the difference between W, m, and Wc, where Fb is the buoyancy force, expressed in newtons. W, m, is the weight of molten metal displaced, expressed in newtons, and Wc is the weight of the core, expressed in newtons. So, we have studied the sand casting operation. Thank you. Here, we come up with new videos on different subjects to make the academic studies easier for you. So, into the topic. Except sand casting, there are other casting processes that have been developed to meet special needs. The difference between these methods are in the composition of the mold material, or the manner in which the mold is made, or in the way the pattern is made. Shell molding is a casting process in which the mold is a thin shell made of sand held together by thermosetting resin binder. Was developed in Germany in the early 1940s. We are going to observe the steps of shell molding in the next few figures. The figure 1 shows the first step in shell molding, where a match plate or copen drag metal pattern is heated and placed over a box containing sand mixed with thermosetting resin. The figure 2 shows the second step in shell molding, where the box is inverted so that sand and resin fall onto the hot pattern, causing a layer of the mixture to partially cure on the surface to form a hard shell. The figure 3 shows the third step in shell molding, where the box is repositioned so that loose, uncured particles drop away. The figure 4 shows the fourth step in shell molding, where the sand shell is heated in oven for several minutes to complete curing. The figure 5 shows the fifth step in shell molding, where the shell mold is stripped from the pattern. The figure 6 shows the sixth step in shell molding, where the two halves of the shell mold are assembled, supported by sand or metal, shot in a box, and pouring is accomplished. The figure 7 shows the seventh step in shell molding, where we can see the finished casting, with sprue removed. There are many advantages of shell molding. The surface of the shell mold cavity is smoother than in a conventional green sand mold. This smoothness permits easier flow of molten metal during pouring and better surface finish on casting. Good dimensional accuracy. Due to good finish and accuracy, the need for machining is minimized. Sufficient mold collapsibility to avoid tearing and cracking of casting. Can be mechanized for mass production. Very economical for large quantities. There are also some disadvantages of shell molding. More expensive metal pattern than the corresponding pattern for green sand molding. This makes the shell molding difficult to justify for small quantities. Examples of parts made using shell molding are gears and camshafts. So, we have studied shell molding, which is one of the expandable mold casting processes, other than sand casting. Thank you. We come up with new videos on different subjects to make the academic studies easier for you. So, into the topic. Except sand casting, there are other casting processes that have been developed to meet special needs. The difference between these methods are in the composition of the mold material, or the manner in which the mold is made, or in the way the pattern is made. Vacuum molding. It uses a sand mold held together by vacuum pressure rather than a chemical binder. Was developed in Japan around 1970. We are going to observe the steps of vacuum molding in the next few figures. The figure 1 shows the first step in vacuum molding, where a thin sheet of preheated plastic is drawn over a match plate, or cope and drag metal pattern by vacuum. The pattern has small vent holes to facilitate vacuum forming. The figure 2 shows the second step in vacuum molding, where a specially designed flask is placed over the pattern plate and filled with sand, and a sprue and pouring cup are formed in the sand. The figure 3 shows the third step in vacuum molding, where another thin plastic sheet is placed over the flask, and vacuum is drawn, that causes the sand grains to be held together, forming a rigid mold. The figure 4 shows the fourth step in vacuum molding, where the vacuum on the mold pattern is released to permit pattern to be stripped from the mold. The figure 5 shows the fifth and final step in vacuum molding, where the mold is assembled with its matching half to form the cope and drag, and with vacuum maintained on both halves, pouring is accomplished. The plastic sheet quickly burns away on contacting the molten metal. After solidification, nearly all of the sand can be recovered for reuse. Advantages of vacuum molding. Since no binders are used, sand recovery is almost a perfect process. The sand does not require extensive mechanical reconditioning normally done when binders are used in the molding sand. Since no water is mixed with the sand, moisture-related defects are absent from the product. Disadvantages of vacuum molding are: it is relatively slow, not readily adaptable to mechanization. So, we have studied vacuum molding, which is one of the expandable mold casting processes, other than sand casting. Here, we come up with new videos on different subjects, to make the academic studies easier for you. So, into the topic. Except sand casting, there are other casting processes that have been developed to meet special needs. The difference between these methods are in the composition of the mold material, or the manner in which the mold is made, or in the way the pattern is made. The expanded polystyrene process uses a mold of sand packed around a polystyrene foam pattern, which vaporizes when the molten metal is poured into the mold. Also known as lost foam process, lost pattern process, evaporative foam process, and full mold process. The polystyrene pattern includes the sprue, risers, gating system, and may contain internal cores, if needed, thus eliminating the need for a separate core in the mold. Since the foam pattern itself becomes the cavity in the mold, considerations of draft and parting lines can be ignored. The mold does not have to be opened into cope and drag sections. We are going to observe the steps of expanded polystyrene casting process in the next few figures. The figure 1 shows the first step in expanded polystyrene casting process, where pattern of polystyrene is coated with a refractory compound, in order to provide a smoother surface on the pattern and to improve its high temperature resistance. The figure 2 shows the second step in expanded polystyrene casting process, where foam pattern is placed in mold box, and sand is compacted around the pattern. The figure 3 shows the third and final step in expanded polystyrene casting process, where molten metal is poured into the portion of the pattern that forms the pouring cup and sprue. As the metal enters the mold, the polystyrene foam is vaporized ahead of the advancing liquid, thus allowing the resulting mold cavity to be filled. Advantages of this process include: pattern need not be removed from the mold. The steps of incorporating cores and gating and riser system, the preparation of two mold halves with a proper parting line, allowances, etc., which are necessary for green sand molding are built into the foam pattern itself. Disadvantage of expanded polystyrene casting process is that a new pattern is needed for every casting. An example of parts made with the expanded polystyrene casting process is automobiles' engines. So, we have studied expanded polystyrene casting process, which is one of the expandable mold casting processes, other than sand casting. Thank you. Like on. Here, we come up with new videos on different subjects, to make the academic studies easier for you. So, into the topic. Except sand casting, there are other casting processes that have been developed to meet special needs. The difference between these methods are in the composition of the mold material, or the manner in which the mold is made, or in the way the pattern is made. In investment casting, a pattern made of wax is coated with a refractory material to make the mold, after which wax is melted away prior to pouring the molten metal. The term investment comes from one of the less familiar definitions of the word invest, to cover completely, this referring to coating of refractory material around the wax pattern. It is a precision casting process, as it is capable of making castings of high accuracy and intricate detail. It dates back to the ancient Egypt, and is also known as the lost wax process, because the wax pattern is lost from the mold prior to casting. We are going to observe the steps of investment casting, or lost wax casting process in the next few figures. The figure 1 shows the first step in investment casting process, where wax patterns are produced. The figure 2 shows the second step in investment casting process, where several patterns are attached to a sprue to form a pattern tree. The figure 3 shows the third step in investment casting process, where the pattern tree is coated with a thin layer of refractory material. The figure 4 shows the fourth step in investment casting process, where the full mold is formed by covering the coated tree with sufficient refractory material to make it rigid. The figure 5 over here shows the fifth step in investment casting process, where the mold is held in an inverted position and heated to melt the wax and permit it to drip out of the cavity. The figure 6 shows the sixth step in investment casting process, where the mold is preheated to a high temperature, which ensures that all contaminants are eliminated from the mold. It also permits the liquid metal to flow more easily into the detailed cavity. The molten metal is poured, it solidifies, and the figure 7 shows the seventh and final step in investment casting process, where the mold is broken away from the finished casting. Parts are separated from the sprue. Advantages of investment casting are: parts of great complexity can be cast, close dimensional control and good surface finish. Wax can usually be recovered for reuse. Additional machining is not normally required. This is a net shape process. Disadvantage are: since many processing steps are required, it is an expensive process. Parts are usually small in size. Examples of parts made with this process are blades and jewelry. So, we have studied precision investment casting, or lost wax casting process, which is one of the expandable mold casting processes, other than sand casting. Thank you. Icon. Here, we come up with new videos on different subjects, to make the academic studies easier for you. So, into the topic. Plaster mold casting. The plaster mold casting is similar to sand casting, except that the mold is made of plaster of Paris, or gypsum. Additives like talc and silica flour are mixed with the plaster to control the setting time, reduce cracking and increase strength. In making the mold, plaster and water mixture is poured over a plastic or metal pattern in a flask and allowed to set. Wooden patterns are unsatisfactory due to extended contact with water in the plaster. The fluid consistency permits the plaster mixture to readily flow around the pattern, capturing its details and surface finish. Advantages of plaster mold casting are: good surface finish and dimensional accuracy, capability to make thin cross sections in casting. And the disadvantages of plaster mold casting are: moisture, because long baking times are required to remove moisture. However, too much dehydration will cause the mold to lose its strength. A balance must be achieved between these undesirable alternatives. Plaster molds cannot stand the same high temperatures as sand molds. They are therefore limited to the casting of low melting point alloys. Ceramic mold casting. The ceramic mold casting is similar to plaster mold casting, except that the mold is made of refractory ceramic material that can withstand higher temperatures than plaster. Ceramic molding can be used to cast high-temperature alloys such as steels, cast irons, and others. Its applications, molds and relatively intricate parts, are similar to those of plaster mold casting except for the metals cast. Advantages of ceramic mold casting are also similar to those of plaster mold casting. So, We have studied plaster mold casting and ceramic mold casting, which are ones of the expandable mold casting processes, other than sand casting. Thank you.